Hi, Living Earth. I promised that I would make a video about how to draw and create a graph. I know a couple of you are struggling with this. I know some of you are like, I already know how to do this. Regardless, if ever you are struggling with making a graph and knowing what I want, you can watch this video and it will help you. So what I'm gonna do is look at this table over here, which I found it on the internet. They're fake people. These are not representative of my students nor their grades. So I just wanted to have that disclaimer. These are not real people, but it is a graphable data table. So let's pretend that I'm taking these fake people and I want to show my fake set of students how their study time impacted their grades. Well, I have a skeleton graph kind of set up, and yes, I did hand draw this on Google Docs, obviously, but I know that the scaling here is not perfectly even, and I know that when you guys draw graphs, your scaling isn't going to be perfectly even either. I'm not looking for perfection from your graphs. I'm looking for you to have a graph that's readable and has the proper elements. So the first thing that we need to do is we need to decide what our x-axis and what our y-axis are going to be. Now, for those of you that don't know, this axis, the horizontal one, is an x, and the vertical one up here is a y. When you are graphing, your independent variable should always go on your x, and your dependent variable should always go on your y. Now, I know a couple of you are probably still struggling on how to identify independent versus dependent variable, and there's a few different ways to do that. But rule of thumb is that your dependent variable is going to be your results every time, results of whatever experiment it is. And your independent variable is the thing that you were testing in the first place. So like for this, if we wanted to see how study time impacted your grade, we would be measuring the grade, which makes this your dependent variable. And since we were seeing how study time impacted the grade, the thing that we were changing or testing in the first place, this is your independent variable. So on this graph, we're going to graph the study time on the x-axis and the grade on the y-axis, which makes each of these sets coordinates. So this one would be 2, 84. This one would be 4, 91, et cetera, and et cetera down the list. And coordinates are always written x, y. Okay, so that's something that you probably learned in middle school, and if you didn't, I'm sorry to say that your teacher in middle school failed you if you were never taught how to do this, because it is something that most students learn at that point. So let's just go down the list and I'm going to graph these points. But before I do that, I have to set up my scale. And the way that you do that is you look at what you have here, okay? So what I have here are numbers, and these numbers range between, let's see, 1 is our lowest and 5 is our highest that I see here. So what I would do, honestly, is I would make my scale on my x-axis going from, let me change my color really quick, I would make it going from 0 on the low end to 5 on my high end, because that would make the most sense, okay? So the question is, well, how do we scale it in between there? So let's see in my skeleton graph, how many little tick marks here do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I could count by 0.5, so I can make this one 0.51, 1.52, 2.53, 3.54, 4.5, and finally 5, okay? So again, yes, this is a little bit messy, but my scale is even, and it covers the entire range of this data. Now here, I have, what is it? My lowest number looks like it's 78. My highest number, let's see if I can find, what, 94, it looks like. So we have choices here. we could do a 70 to 100 scale. We could do a 50 to 100 scale. We could do pretty much anything. You do not have to start at 0 if you don't want to, and if your data doesn't reflect this. So what I'm gonna do here, I'm gonna extend this just a little bit. I think it might be smart to just start at 50 and maybe count by 5s, because I have, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I went 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, that would represent my data fairly well. And yes, I would be graphing points up here, but again, that's okay. So I'm going to do that. I'm going to say 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Okay? Your next task is to label your axes. What are these numbers? What are these numbers? So these numbers are study time. So I'm just going to write study time. And then I'm going to put in parentheses hours, because this is study time in hours, not in minutes. Now on this side, this is the student's grade. So I'm just going to write grade over here. And if you wanted to be a little bit more specific, you could say percent or score or whatever it is, but given this table, we don't know if it's a percent or a score, or even if it's out of 100. So I'm just going to leave it at grade. Okay? Now, we're going to start graphing our coordinates, and we're going to go just in order, right down the list. So we have 284. So I'm going to go to 2. I'm going to go all the way up to approximately 84. Obviously, my scale doesn't go by 1, so we're going to approximate. We're going to put a data point right there. We have 4, 91. So again, we're going to approximate. We have 592. We have 389. We have 488. It's going to be right below there. We have 493. Just right above. We have 178. We have 2,89. So just a little bit higher. We have 5,94. So that looks like our highest so far. And last but not least, we have 2.5, 87. That's going to be right about there. Okay, so the question that we have left, other than giving our graph a title, is what kind of graph is this? Is it a line graph or is it a scatter plot? Now, line graphs and scatter plots sometimes could be interchangeable, but really a scatter plot doesn't have a clean line, and a line graph has basically one data point at each little scaled tick mark, and so it forms a nice line even if that line is not straight. So what this looks like to me is a scatter plot, because we have data that's forming a trend. And if you'll notice, I'm going to do this in kind of a light color. Sometimes with graphs, especially scatter plots, you can form something called a best fit line, and that's a line that's an approximation of what your data kind of does. It doesn't mean that it's exactly what your data points are, but if I had to draw a best fit line, I would kind of guesstimate it to look something like this. And you may have seen this at times in graphs that you've seen before. This is an average, approximately. It's not saying, hey, all my data hugs this line. It's just saying this is my average trend that I'm seeing. And you could even do an equation for that line, but we're not going to be doing that in this class. Now, this is a scatter plot because look at how these dots are not cleanly in a line. if I had had a graph that, you know, let me just do this in a different color. If I had had data points that looked like this along this line and rose cleanly like this, that would have been a line graph. But it's not. If I had had bars and categorical data, it would have been a bar graph. And I can show you a bar graph at a later time, but this is a scatter plot, and this is how you would graph data like this. And if I had asked you to analyze it, like what trend do you see between study time and grades, an acceptable answer would be, well, I see an increasing score roughly mirroring the amount of study time. Are there outliers? Are there people that studied less but got a higher score than people that studied more? Yeah, sure, absolutely. But on the whole, you see an increasing trend. When you study more, you tend to get a higher grade. Okay? So I hope that was helpful, and I will post this on Canvas for you to view.